Okay, so welcome to the webinar organized by Triangulum about data platforms. Just for your information, I will mute all of you for the time being so that we don't have any background noises, and I will make the speakers presenters for the time of their presentation to make sure that they can go through their slides and everything by themselves. If one of the listening participants has a question or would like to say something, please just type it in the chat box that you should see below. And we can then see whether we answer the question just like this or whether I give the microphone to you. Okay, so the topic of this webinar is data platforms. We are starting now at 10 and we think it will last for about 2 hours, so until 12. We have 3 speakers here from all of our 3 lighthouse cities of Triangulum. Rick Schager will talk on behalf of Eindhoven, our first lighthouse city, about the topic of Eindhoven as a living lab, bringing it all together. After him, Ettore Murabito from University of Manchester will speak about the why, what, and how of a smart city data platform, considerations and lessons learned. And the last one will be Russell Wolf from the University of Stavanger, speaking about Stavanger's approach to data platforms. Each presentation will last about 20 to 30 minutes. And after each presentation, we will give you, the participants, the chance to ask very urgent questions. Please also ask these questions in the chat box below, and we will answer them immediately. After all 3 presentations have been held, we will open it up to a very general discussion, so where you can ask just more general questions or anything that hasn't been mentioned yet and that you would like to discuss. Okay, so far from my side. Now I think I will give the word to Rick Schager from Eindhoven so that he can start his presentation.
Okay, Bettina, thanks for introducing me. I don't know whether I can share my screen already.
Yes, it should work now.
Yes, it works.
Yeah.
Great. Does everybody see the first picture with Triangulum, etc.?
Yes, that's fine.
Yes.
Okay, great. Well, I'm Rick Schager. I'm working as an IT architect within the municipality. That means that I'm doing all kinds of technical stuff to keep our local infrastructure from workstations up to servers and storage up and running. But besides that, I'm also very heavily involved in living labs, IoT, smart cities, etc. I worked for the Triangulum project and together with all kinds of other colleagues and together with other lighthouse cities, and would like to share the view of our city regarding open data and data platforms. In Eindhoven, we call it the smart society. So not only city, but we want to include all citizens to have a real added value for all parties, not only local or central government, small and large businesses, knowledge institutes, but mainly for citizens. In Eindhoven, we are using the total city as a living lab, because we have an approach to innovation that just try it. Don't think too long, try something, and if it don't work, no, don't worry, try it again, learn from it and make it better. We started a couple of years back with ambitions, as you can see here. We would like to use data and smart technologies to make the life for our citizens and the surroundings better. You do it with people. We partner with all parties, small and large, in our neighborhood. We work together, we create together, and we experiment. What I'm gonna tell you more today is an overview of our current environments, data platforms, living labs, etc. How we got them integrated at least to one open data platform, and what we did, let's say lessons learned, how we got to this state, and what we're trying to do to bring all together. It started more than 5 years ago in the Stratumswand. That's our pub street. They say it's the longest pub street in the Netherlands. And we studied there with all kinds of sensors, the effects of lighting, colors used, and temperature on human behavior. It started just as an experiment. There's a lot of sensors placed there, measuring sound, measuring movement of people. We did it in co-creation with Atos and the Technical University of Eindhoven. And well, the data is actually part of the solution. Well, we started there. Also, a couple of years back, we did the Roadmap Light. That's kind of innovative procurement procedure, where we, as municipality of Eindhoven, well, undersigned an agreement providing a long-term strategic partnership with the winners of this tender, and these are Philips and Heijmans. There are all kinds of testing grounds, different testing grounds, not only replacing the old bulb lighting, street lighting by LED lighting, but also including citizen needs, what you really need, can do with light on the actual needs of people, and create some use case from that. In these 5 areas we will experiment, and well, data is not really part of it, but we're trying to bring IoT measurements, light data, people counting, figures from health, etc., all together on one platform. Another initiative in our city is Areas. It's well, a citizens volunteer-driven initiative. Sort of, well, more than 33 of these boxes envisioned in the yellow circle are placed throughout the municipality, providing all kinds of air quality data and providing you all the data harvested each 10 minutes of all these 33 sensors. It's available in open data. It's free for use, for reuse. And one of the initiatives is showing you the R quality index throughout some days in the graphs on the left-hand bottom side. Within Triangulum project, we did a district platform in Stripe-S as a new development area where the abandoned factories from Philips bulbs were there. In Stripe-S, there was a district-based approach. We used multiple data sets. There's multiple use cases, and focal vessels I city. Some examples what we did here. There are some parking places in this area. We've got a live feed on the internet and on app available, showing you how much free spaces are still available on these parking spots. You can see that we have actually an RSS feed. We translated that via our own open data platform and created together with Stavanger, and that it is part of the cloud data hub within Triangulum to provide also this data over there. We use more data not only for mobility or smart mobility, also for energy, smart offices, and lighting scenarios. Well, this is a picture of our open data platform. It's of course open, freely available for everybody. It includes all kinds of internal municipal data available for everybody for outside analysis, but also for internal data-driven analysis and decision-making. And like there's some for areas, there are also real-time data sets over there. Well, that's all nice and well. What's under the hood? Well, very kind of spaghetti-like environments, which we try to get aligned. So in the blue box bottom, you see all kinds of internal municipality sources, which are extracted with kind of agreement between the source owner and the processor. This kind of, well, service level agreement, more or less. Provided in data warehouse and in a more or less geo-based data warehouse. Then we've got a decision tree in place where the data steward decides whether these data sets are can be made open, available on the open data platform. One of these questions, of course, in this decision tree is this linkable to persons and not, well, if we should publish, it's not GDPR proof. In the green box on the left-hand side, we can link or harvest all kinds of external open sources. On the top, we've got some vertical IoT solutions, like the one I just showed from Triangulum, like the one we are willing to or planning to create within the Philips Hyman smart lighting environment. And we got some city sensor networks on top in the blue box with city beacons, with traffic light controlling areas and these areas boxes. And of course the starting plans, living lab data. We are working on one harmonized urban platform to have a horizontal layer on top of all these vertical initiatives to bring all these real-time or not real-time sensor data or other data, streaming data, all data, legacy data, whatever data you've got, bring it together in context to each other in standard formats to this Eindhoven, our own open data portal, federated to other municipalities, cities within the country and within Europe. For instance, like dataoverride.nl. That's our national data portal. Well, some of the sensor data, like camera feeds in the public domain, guarding if there are not incidents happening, we share with, let's say, the red box, the external closed box, for instance, with the police, so that de-escalation of fights, etc., can be achieved. How we got there? Well, use cases first. So what do you want to achieve for your environment? We participate in European projects. Besides the Triangulum Horizon 2020 project, we also participate in Synchronicity, in ROC and in UNILAB. We focus on what we call the quadruple helix model. So working together with small companies, large companies like Philips Heijmans, work with knowledge centers like the Technical University, work with citizens themselves like the ARIES initiative. Also with other governments in, like for instance, the state or the national governments like the police, etc. We developed the vision for the future on platforms. There is a report brought out for our strategic department. More or less summary, there is no clear winner of smart of platforms. For there's not one size fits all. So focus on standards of being open, being interoperable, being expandable, work with APIs, work with generic components which are exchangeable. And last but not least, dare to try. Just innovate, small investment, try something and see if it works. Learn from it, try it again and achieve something. What did we achieve in the meantime? Is, for instance, the starter kit, for instance, this open data portal and all kinds of nice input for all European projects, standards, national, etc. What did we learn from our, let's say, tender for purchasing this new open data portal, which we used in the Triangulum project? Well, the quality, the usability, and keeping things good up and running were for us more important than the money spent and the time spent. We did a market consultation asking all kinds of, let's say, silly questions to all parties which know something. Take this knowledge from the market, include our vision, and then do an RFP. So very clearly uncouple it and take sufficient time to translate market knowledge into the tender. Eat a large elephant in very small pieces. So keep the complexity low, start small, and allow for organic growth and be flexible. What we have learned in Eindhoven, which is the 5th city in the Netherlands, but in world scale with 230,000 people, not that big. But even in this city, there's room for parallel development. In Living Labs, we try, share knowledge, and integrate later. Also, business models can vary. But then, organic growth, in some time, you need guidance, you need integration, you need something to make things share. To share knowledge, to have it interoperability, to go for standards. Well, bring it all together. We worked for 5 years. We brought all our knowledge together, our experimental knowledge in the starter kit. It provides you some technical stuff, some policy stuff, and some legal stuff. It's more or less our shared vision within the city of Eindhoven, so together with municipality, technical university, etc. It was done together with the Dutch Institute for Technology, Safety and Security, ATOS, Netherlands, Technical University, Creative Ring, and all kinds of local parties. Well, we have on technical part, we have a beta environment, data factory environment available. This includes these various air quality measurements to provide the kind of dashboard just displayed here. This is all based on firmware components, all based with open APIs, standard data models, and the source is freely available on GitHub. Well, if you've got time on your hands and money to spend, please come to the Eindhoven. We've got our Dutch Design Week upcoming from the 21st to the 25th of October. The Creative Ring has a summit there. We are also explaining the way how we did this, including a workshop and on laptop with administrator light, you end up with a working technical version of the starter kit. Another picture. How did we do that? Of course, you're talking to a techie now. We started with the Triangulum reference architecture, just displayed here. We started within our living lab at South Bend. We got some older proprietary environments with a controller and all kinds of stuff. The first step we did, we coupled all the IoT sensors in, well, what's the color? Kind of reddish color in the bottom, via all kinds of network mechanisms from fiber up to Zigbee, etc. We created 4 firmware generic enablers together in a package and ended up with the dashboard shown there. Then again, we said, well, that's all nice and good. We need something else. We need authentication, authorization. We need something that events can be processed together and fed back to the environment. We need big data analysis. We need some kind of model to bring these data, these raw data, to value-added information and bring it to the market and share our knowledge through all our living labs. Well, what we did is brought all this knowledge in all the platforms we know, locally integrate all the living labs, did it regionally in our Brabant Brainport area, together also with Antwerp in Belgium. We brought it to national level on the NEN, the Dutch Normalization Institute. We brought it to the Association of Dutch Municipalities, and it was included in the Dutch Digital Agenda. We also brought it to Europe, to the EMEA, to Eurocity, to the ANO, to the Horizon projects like Synchronicity. We brought it to OWASP, we brought it to SCORE. What you see here is just a small part from the total environment. It's just a data factory bringing the sensors with open APIs based on standard components, based on standard data models, and bring together in an open database. That's what we've got. Well, how do we think we can go further? We think that if you want to go for a European digital single market, that harvesting data is, well, it's a challenge, but it's solvable, it's doable, but that you need to talk the same language. So data models become key. And of course, not keeping this data just for your own Eindhoven municipality or your own regions or your own nationality. Share it and federate it wherever possible throughout Europe. This brings all kinds of questions, of course, on technical level, how to connect that, but also who manages, how's governance arranged. Think about who decides what quality the data is. Think about the value of data related to these previous topics. And of course, the business models behind it. So, raw data, in our humble opinion, should be shared openly and freely for everybody. But if there's real added value in killer apps or nice value-added information, we could discuss a healthy business model with pay per use for something nice. And yeah, keep in mind, why are you doing it? Just don't only make data available on an open data portal just because you can, but what's the real added value for the citizens and the environment? Well, that's more or less it. I've got one slide which I could do, but I think it's more handy given the time that I stop this presentation here.
Okay, thank you very much, Rick. It was very interesting to hear what Eindhoven has been doing on the topic of data platforms, so thank you very much for this overview. If there are any urgent questions from the participants, I would like to ask you to please indicate it quickly in the chat box, and then I will give the microphone to you so that you can ask your question. So we will just wait a few seconds in case there are some questions. Okay, I think it's fine. We also, oh, there's one. I have a question about the dashboard. Okay, Russell, I'll give you the microphone. Just a second. Yeah, no, you can speak.
Hi, I have a question, a quick question. You mentioned something about having the source available on GitHub. Was that the Grafana dashboard software you were talking about, or your own dashboard that you have developed in Grafana?
Actually, both. So
okay.
in Synchronicity, we learned from another city, I think it's Milan on top of my head, that they use Grafana as open source for kind of dashboarding tool. Of course, we just got it from GitHub. We are struggling still in beta, which is the best version to use, but it's really available. It works nicely, it displays nicely, and everything we learn, of course, goes back to GitHub.
Okay, so do you know if there are? Could you please share a link to what you have developed on on top of Grafana?
Yeah, what we've got in this starter kit is available, is downloadable as VM, as script, and then you get free all our areas data with how it's publicized. I don't know how it's scripted because that's not my expertise, to be honest, but I can sure via Bettina share a link to this environment and get some knowledge how they did it, because it's not my cup of tea, to be honest.
Oh, that's fine. As long as if you could just share a link, that would be great. Thank you.
Okay, welcome.
Okay, we have one more question. I'll give you the microphone. Oh yeah, you have it already. Okay, you can speak now. Hashita? Can you speak? Okay, you can also ask the question in the chat window. That's fine as well. We'll just wait a few more seconds. Okay, the question is regarding the fireware kit. Is it still not a compact and runnable solution yet? I see that it needs a lot of cross-change to finally make the setup work, which becomes a bit difficult to use it for education. Rick, can you answer that?
Yes, this is more a statement than a question, to be honest. Well, this is a statement which I do not fully agree, but I can share the source codes, etc., and I can also state that in the Technical University Eindhoven, they have used this fireware kit with this script and had it up and running in 2 hours. Is it complete? No, it's just a first step from getting sensor data, place it in context, and store it in a Seekem-based environment and have a real simple, not fireware compliant, actually, Grafana dashboard on top of it. That's it. Is that sufficient as answer? I hope.
Yes. Okay, thank you. So we have one more question by Nikolai. What is the role of fireware in the presented activities?
Fireware role, if you mean the Fire Foundation organization as a, let's say, kind of quality assessment of fireware components, in Synchronicity platform, there are partner, so there are aligned involved. If you mean fireware as, let's say, a repository of components and or data models, yeah, we use them as is and share it back to, let's say, GitHub environments of both the components and the data models.
Okay, thank you very much. I think we'll finish the question round for the first part for now. If you have more questions, we will be very happy to discuss them at the end of the webinar. So, Rick, thank you again very much. And I will now make Ettore a presenter so that he can start with his presentation.
Thank you, Bettina. Let me share the screen. Can you see my screen?
Yes. Yes, thank you.
Okay, awesome. So Smart City Data Plan, you can see. Okay. So I think I will start probably by stating the obvious here in this presentation by saying that although a definition of a smart city might not be completely unambiguous, there's a general consensus that, the transition from a more traditional city to a smart or smarter city, if you wish, is enabled by digital technology and the use of data. So the idea is that a data-centric approach is beneficial for improving the management and the delivery of the different services and functions in the city. And in this sense, Triangulum makes an exception. In Manchester, we are focusing on three main areas of interest: energy, mobility, and ICT. And the ICT element seems to be understood mainly as being at the service of the other two modules. So the ICT aspect of the project is not only, but mostly concerned with making a case for a data-centric approach in the management of specific domains of the city. Now, why is this the case? Well, because there's a general understanding that data can be used to enable better informed policies, to assess the impact of such policies, to promote the creation of value, and to promote also citizen engagement. So all of these are big promises, and there is a push to make a strong case for the use of data. Now, in regard to data platforms, there's a lot going on in the software industry as well as in research projects such as Triangulum itself, in trying to define the scope of a smart city data platform and the kind of services it should provide. Now, there are, however, very obvious commonalities among all the possible implementations you can think of. One is obviously data collection, because there's no data platform without data, and the other one is data provision, because there's no usefulness for a data platform without, if it doesn't provide access to the data. To implement these functionalities, in Manchester we used an out-of-the-shelf product for our data platform. This product is called Pi and was developed by OSIsoft. Pi is basically a software suite that was created for enterprises to manage real-time data and events. When I joined Triangulum, which was roughly 1.5 years after the project started, Pi was already installed on the servers of the University of Manchester, although later we went through a major reconfiguration of both hardware and software. But there was at the time a strong indication towards using this product for Triangulum. And the reason is quite simple. On the one hand, OSIsoft was interested in penetrating the smart city market and see how their product could be used in this context. And on the other hand, the university benefited from a free academic license. And on top of that, using Pi relieved us from the heavy lifting of creating a platform from scratch, basically. So this was a win-win sort of solution, if you want. Now, this is an extremely simplified representation of the different components of Pi and how they fit together. So you have the interfaces on the left. The interfaces are specific software modules of Pi that are in charge of collecting data from a variety of sources and through different protocols. There are, I believe, over 100 of these interfaces. However, we are only using a very limited number, mainly the HTML interface that can read data from web pages, and the UFL, or Universal File Loading interface, that can read data from files such as CSVs. These interfaces run on dedicated machines, and there's a failover mechanism so that if a machine goes down, the interfaces will run in the secondary machine and vice versa. So the interfaces read data from the data sources, timestamp this data, and send it over to the data archive, which is the core of the Pi system. And even here, there is a failover mechanism in the sense that we have two servers, one primary and one secondary, that both serve as archive. Now, the raw data that the data archive receives consists of streams of numbers. Actually, I should say streams of values more in general, with their own associated timestamps. However, the raw data can be represented in a way that is more human-friendly, and that can mirror the hierarchical structure of the different assets from which the data is collected. And this is done through the AF server, AF standing for Assets Framework. Basically, the AF server contextualizes the raw data by adding metadata. In this way, the data can be represented internally, but also exposed externally in a way that, as I said before, mirrors the hierarchical structure of the different assets. In this case, for example, we have divided our data sets in 4 main sectors, representing the main domains of interest that the data refers to, so like air quality, transport and mobility, utilities, and weather. But you can also subdivide these items according to other classification criteria that make sense to you. For example, in this case, we have a geographical subdivision of the air quality data, as this data is collected from a number of monitoring stations around Manchester, not just 2, as you see here. Actually, this is an older snapshot. We have like 10 to 15 monitoring stations now. Going back to the previous slide, finally, the data can be retrieved by the end user in a variety of ways, such as SDK in a web API and various visualization tools. These are examples of the kind of visualizations we can produce. We can generate geographical maps to show data that has a geographical, how can I say, connotation. And this is done through another piece of software, which is also proprietary and is called EsriGIS. In the map here, you can see dots of different colors and size. Every circle represents a car park. The size of the circle tells you how many free spaces there are in the car park. And the color of the circle tells you whether the car park is full or closed, in which case the circle is red, or open with free spaces, in which case the circle is green. You can also click on a circle and see more information, numerical information pertaining to that specific data element. The cool thing here is that these maps can be embedded in web pages, so this is a very handy feature to have. On the right, you see another visual that was created through a native module of Pi called CoreSite, and it provides you with an easy way to represent data that does not have a geographical connotation, or for which you don't have at least a geographical information. The good thing is that these visuals can be accessed via a simple URL. So this is, again, quite handy, although there are limitations, as I will see, I will explain later. Yeah, so Pi comes also with a web API that can be used to access the data programmatically. We provide some documentation about how to use this API on a website where people are also able to download the data manually if this is what they prefer. The manual download mechanism was created by us and is based itself on the Pi web API. So it's actually a front end for the web API. And here I would like to illustrate a typical data flow from the data provider to the data consumer. So in this example, the journeys data of cargo bikes, which are used in Manchester for last mile deliveries, is collected by Autotrip, who provides the trackers fitted on these bikes and plays also the role of data source for Triangulum. Triangulum uses a Python script to query the cargo bikes data via the Autotrip web API. The result of the query is saved on a CSV file, and finally the CSV file is read by the UFL interface, and its content is sent to the data archive. And this is done repeatedly at regular time intervals. Once the data is on our archive, it can be accessed by the end user via, for example, our web API. Now, this seems maybe a little bit convoluted, but it's actually quite straightforward. And this is just another example of the same process, with the difference that in this case, the air quality data is read from a web page, which refreshes itself every hour, if I remember well. And we read this data from the web page using an HTML interface, and we pass this data directly to the data archive. All the rest is pretty much the same as the previous example. Okay, now I would like to give you a couple of examples on how the data collected is being used. Before I mentioned that a data-centric approach can be used to assess the impact of specific policies, right? And this is something that is happening in Manchester in the context, for example, of mobility. We have a number of electric vehicles deployed in the fleet of the 2 universities in Manchester, which are procured via Triangulum, by the way. And by measuring the usage of these EVs, we can estimate how much of specific pollutants we are not emitting into the atmosphere. And this is one way of capturing the impact of this mobility scheme. But there are also other ways, like, for example, the cost effectiveness of using EVs instead of conventional diesel vehicles. And in this regard, I should mention that you can charge your EV for free in Manchester, at least for the time being. So there's an economic aspect to this that we are also able to capture. The same concept can be applied, and is applied, in fact, to other alternative means of transportation, of which we can track the movement. For example, the electric cargo bikes that I was mentioning before. Just incidentally, I would like to mention that these figures are calculated based on quite strict requirements in terms of pollution allowance, so to speak. So these numbers are quite conservative. Another example on how our data can and is used is provided by what we call behavioral change campaigns, where we try to engage people in an effort to change specific habits or to become more involved maybe in community efforts to address specific issues. To be a little bit more concrete, let me give you an example. This is a dashboard that was created specifically to run energy-saving campaigns at the University of Manchester. We put some effort to make this data meaningful to people. So if the energy consumption of a building in a given time span decreased or increased, for that matter, compared to the same time span last year, then we can see the magnitude of such change, and we can understand it in terms of things we care about, like, I don't know, the, say, health level of the polar ice caps, or in terms of things we can relate to. For example, how many miles do I have to ride on a bike to amount to that change in energy consumption? The time spans considered in this dashboard are the last day, the last 7 days, and the last 30 days. We are also collecting data that we don't currently use because it doesn't directly contribute towards the impact indicators we have in Triangulum, but this data could turn to be quite useful at some point. Going back to mobility, an example is provided by the geolocation data of the cargo bikes. This data could be used to analyze the preferential routes of the people resorting to the cargo bikes. For example, why these streets are preferred, why other streets are not, why different choices are made at different times of the day, and so on. And by doing so, we could think of possible venues of intervention to improve the cycling experience for cargo bike users, hence encouraging an even wider use of these bikes. I would also like to mention that there are different smart city projects running in Manchester. One is CityVerve, another one is Synchronicity, already mentioned before. And both are mainly, but not only, involved in the development of an IoT market of products and services. Now, these projects are interested in some of the data that Triangulum has, and we provide them with this data because it is easier for us it is easier for us as Triangulum to tap to the original data source thanks to specific agreements we managed to have with some of the data providers. And it is also, a little bit pointless, I guess, from these other projects to replicate work that has been already done by us. So we can say that Triangulum is boosting and facilitating further progress in the direction of other smart city activities. Now, all of this sounds, I think, pretty good and nice, but is this an ideal situation when it comes to the specific implementation of our data platform? No, I wouldn't say so. It was convenient and still is, but this solution is not very well tailored around the requirements of a smart city data platform, I think. As I said before, Pi was created for enterprises. And as such, it was conceived mainly for internal use within an institution or within a company. So this means that the main drawback here is about data provision. For example, some of the visualization tools provided by Pi are not reachable from outside the university campus, which limits a lot their usefulness. And other visualization tools can be reached from outside the campus, like, for example, the car park map or other kind of maps. But these visuals cannot be created on demand by the end users. So in a way, they are well, not static because they're live, but immutable from an end user perspective. For this reason, there must be an element of coding and software development from our side, which is totally fine, in order to compensate for these limitations. For example, the energy consumption dashboard I showed you before, here we are, was created by using a JavaScript library, basically. But then again, these dashboards and other data accessibility tools that we created rely on the Pi Web API, which was not designed having in mind smart cities and citizen engagement. For example, only users of the Windows domain where Pi is installed can access the Web API normally. And this is quite impractical because you have to create a Windows user for every citizen or institution that wants to access the data. The alternative solution, there's an alternative solution, fortunately, which is the one we currently adopt, is to have no restriction at all on the data via the API. This means that anyone can download data, provided we set the data visibility accordingly, without the need to give an API key, for example, or some sort of credentials. This means that we don't have, on the other hand, this means that we don't have control on how often and frequently this data is accessed and what is the volume of data requested by every user. And this can potentially lead to overloads. If someone creates, for example, a poorly coded script that queries large amount of data with a very high frequency. Now, fortunately, we don't have this problem, not for now at least, because I guess there's not a high enough level of citizen engagement at this point. But surely we want to move towards that goal in that direction. And this will expose us to this kind of problem sooner or later. So what are the solutions? If you want to be lazy, we could migrate altogether to other platforms that have been thought and conceived to serve in a smart city context. Some of these are proprietary, like OpenDataSoft or GeoSpark, and others are open source, like Fireware, it was mentioned before, and Car. In this regard, there's a general concern that smart cities could become a far west for vendors, if you allow me the expression. So the fear is that what happened to personal computers with the Windows operating system back in the days could happen for smart cities. I personally tend to prefer open source solutions as they can help cities to avoid getting locked into a specific vendor's ecosystem. Also, open source solutions tend to adhere more to standards, whether these are de facto or officially recognized standards. And this makes it easier to develop and expand on top of these platforms. In our Triangulum adventure, we also face other challenges that are not necessarily technical in nature. A lesson learned, for example, is that you need to have some sort of strategic or mutually beneficial collaboration with the data provider to ensure some degree of reliability in the data flow from the source to the platform. Autotrip, which I mentioned before, is not a partner in the project, but we needed them to collect the data coming from the cargo bikes, which were part of the Triangulum mobility work package. And this gave us some headache, to be honest. We were not a priority for Autotrip, and quite understandably, they could not see the point of investing time and man hours on something that they wouldn't directly benefit from. So when it comes to these kind of problems, you need to be a good seller. You need to be able to tell a compelling story about the benefit of participating in these kind of initiatives. Maybe sometimes you have even to appeal to people's ego and makes them see how cool it is. Well, I think it is cool actually, to be a pioneer in this kind of initiatives in this transition towards a smarter city, even if there might not be an immediate return for the work done, apart maybe from a return in image. So essentially, you need to be a good seller and a good storyteller. Said that about Triangulum. As I mentioned before, there are a number of smart city projects running in Manchester. Now, there's an ambition for all these projects to leave a legacy to the city, that remains something that remains after the single projects come to an end. The common denominator of all these projects is obviously the use of data. So our vision for this legacy is to have an open data platform that manages data at the city level as an active ongoing process. And at Triangulum, we also came up with a name for this long-term vision, which is Manchester Eye. Manchester Eye would serve different purposes, but mainly it would serve as a city data portal. So we all know that there's a lot of data around us. Everyone, every institution, every company is producing data of some sort nowadays. But this data is sometimes hard to find. Sometimes we don't even know what data is available. And if we know the what and where, we might not have the skills to access or consume this data in a proficient way. So we believe there is a value in creating a portal that allows citizens, SMEs, academics, citizens in general, to easily access this corpus of data that is produced by different actors in the city. So the idea is to go from here, from this situation to this other situation, where people can have a unified, as much as possible, comprehensive, and as much as possible, user-friendly way to access the city data. Well, I will skip this because I think we could easily run short of time. So how do we get there? Well, first of all, we have to talk about this with other people involved in other smart city projects. And this is a difficult conversation because there are so many things to consider, different ideas about implementation aspects or organizational aspects, and there are more questions than answers sometimes. Triangulum specifically is moving in that direction, in the direction of this Manchester Eye notion, in a couple of ways. First of all, we are enlarging our data set beyond Triangulum's needs. So, for example, we are collecting air quality data from a number of monitoring stations around Greater Manchester. We are collecting weather data and even mobility data that is not strictly relevant to Triangulum. We also started to collect other kind of data based or maybe inspired by the possibility of a collaboration with other projects. For example, the Grown Green project, which is part of the Horizon 2020 framework, is concerned with the water level of rivers and canals in Manchester. And they are considering to use the Triangulum data platform as their data repository. We also decided to give Manchester Eye an official and recognizable face through the website manchestereye.com, from which you can download the data manually or programmatically. The instructions are there. And where people can learn about this vision. So this is a website also that serves an educational purpose, if you want. People can learn about this vision and can also download, as I said, the data collected through Triangulum in a fairly user-friendly way. In November last year, we hosted an open event at the Central Library where we launched, so to speak, Manchester Eye, and we shared with the attendees our vision of what Manchester Eye can become for the city. Now, surely a simple website with a download page is not going to exhaust the discourse around Manchester Eye, which should in turn become a discourse city data management more in general. And I would actually like to end my presentation on this note, namely the fact that data-enabled innovation in a city cannot be decoupled from a new approach to governance. And the vision that the city has for, say, the next 5 to 15 years strongly influences the choices that are made in designing and implementing the city data infrastructure. So these here are some of the open questions that are still subject to a lot of scrutiny, I believe, in this field, and not just in Manchester, but in general. I'm not going to read all of them by one, but in essence, all of them have to do with the approach that the city wants to adopt in regard to data and how the city envisions data becoming part of a new culture in the administration of the city itself, which I believe possibly the main challenge we face. And I think I will stop here. Thank you.
Okay, thank you very much, Ettore. It was very insightful. We already have one question by Nikolai in the chat box, and he's asking whether you're following the activities of the EIP Marketplace and Dienstwerk Open Urban Platforms, since they aim at avoiding vendor lock-in through open interfaces and reference architectures. Nikolai, if you want to add something to your question, you can also speak up if you want. Okay. Otherwise, maybe Ettore, you can answer already.
No, I have to say that yeah, when I entered the Triangulum project, we were in a bit of a rush to produce some results. So I started using what was available and what was indicated as the platform to use, at least for the time being. And there was a lot to do actually. So I was more concerned with making that platform work for the better and satisfy most of our needs. And I have to say that Aussiesoft has an excellent, to be honest, support team. But you know, as I said, we started to face the limitations of this platform, and although they're not a problem now, I hope it will become a problem later, in the sense that this means that we will have more citizen engagement in the future, and this is really what we want to have. Now, I only started very recently to look around to see what other options are, because I was too busy to make the current options, working fine. So I've, just to repeat myself and to answer your question, I've only started to look into these other possibilities, other alternatives only very recently. And I admit I don't know much about them. I'm still studying and documenting myself.
Okay, thank you, Ettore. Nikolai, does that answer your question? Okay. Then we also have another question by Delia from Eindhoven about citizen engagement. Delia, do you want to speak? Delia? You should be able to speak if you yeah, okay.
Hello?
Hi.
Yes. Hi. Good morning. Thank you very much for the presentation. Even for me, who I'm mostly a generalist, let's say, it was very easy to digest. Thank you for that.
Thank you. Thank you.
Yeah. I was curious about some concrete examples about the citizens' engagement. Maybe I didn't get it very well. Could you add on that aspect? How did you engage the citizens so far? Or how do you plan to do that? Thank you.
Yes, well, thank you for the question. I'm not following the citizen engagement personally, so I'm not too exposed to that element of the project. But we have, as I mentioned before, energy saving campaigns running at the University of Manchester. The next one will start in November. And so the idea was, how can we use the data to make an impact in this regard? So we thought that data per se is not particularly interesting unless you make it interesting. Now, if you look at the dashboard full of numbers and complicated graphs, unless you're a student or maybe a member of the staff of the engineering department, all that would be good, I guess. But if you want to talk to the majority of people, people that maybe are involved in humanities, they don't want to spend more than, sorry, maybe I'm being judgmental here, but it's not my intention. They don't want to spend in front of the screen more than 10 seconds and before getting a sense of what the data means. So the idea was to create these kind of dashboards, of which I showed you one, to make this data talk to people in a way that capture their attention, and they in a way that they can relate. So, for example, global warming is a big topic. So if I can understand the data in terms of how many cubic meters of ice I'm saving from melting if I reduce the energy consumption, that's maybe something that people can understand and people can relate to. So that was the effort in creating these kind of visuals. Mm-hmm. We also create running what we call innovation challenges. You can think of innovation challenges like more like hackathons, if you want, with the difference that you don't have to be a coder in order to attend one of those. So you can be a designer, you can be just someone who has a specific issue at heart and wants to contribute with an idea on how to use the data for addressing the specific issues. So we had already one of these innovation challenges. I don't remember when exactly. I think it was March this year, around the concept of energy, specifically how to save energy in the campus, or in a sub-campus, I should say, of the Manchester Metropolitan University. And another one will be held in October. So actually this month, at the end of this month, it will be more centered around the theme of mobility. So this is how, this is what I know, at least, about citizen engagement. This is this is part of the ways in which we are trying to reach to people.
Mm-hmm. And did you already have some feedback, some numbers, how responsive the citizens were on these approaches?
I don't actually, and I am very, very curious to see how the energy campaign is gonna roll out, because I spent a little bit of time and thinking on putting those dashboards together, not just me, other people as well. And I'm very keen to know myself, actually, if this has an impact that is measurable.
Okay. Thank you. We would be also curious if you have some feedback and some numbers, then would be really great if you could share this with us as well.
Absolutely.
Thank you.
Thank you.
Great. Thank you.
Okay, thank you very much. So I think we'll stop here for now. Ettore, thank you very much once again for this very, very nice presentation. And we'll then move over to the last presentation for today by Russell Wolf from the University of Stavanger. So Russell, I will make your presenter now. Okay, you should be able to speak now. Yes, we can already see your presentation.
Great. So hello everyone. I'm going to briefly talk about the concept of smart cities and how the data can help us. I will then talk a little bit about some of the concerns on our side, the developer side, and also the end user side. And then I'll just go from here. So what is a smart city? A smart city is an urban area that utilizes different types of data gathered from a variety of data sources and tries to manage the assets using data more efficiently. And these data sources might be anything. It can be from motion sensors, CCTV cameras, etc. So the data generated by humans is exponentially growing. It was estimated to be about 55 exabytes of data around year 2000, and right now it's around 8,600 exabytes. An exabyte is 1 billion gigabytes. So we need to be able to harness this data. There are many ways this data can help us. One of them is to help make energy systems more efficient. So on the data on the consumer side can give information on how to optimize the usage in their homes, in their offices. It is also possible for the user to get suggestions on how to lower the consumption, for example, in the form of replacing an outdated fridge or renewing the building isolations. At the same time, it will be useful to predict the load on the power grid, because if the load is going to be erratic, it can cause instabilities and the shutdown of the whole power grid system. Knowing more about the traffic might help us in better managing it, from changing the duration of traffic lights in peak hours and during night times to rerouting and redistributing the traffic in places with less traffic. When having a high amount of data, it is possible to fuse all of them, or some of them at least, together and get a more clear picture of things. For example, using weather data with transportation or energy usage. If a certain weather causes more traffic, it will be shown in this fused data. And so people, so the government or the authorities will be able to manage it, well, at least easier. With the advent of IoTs and houses in houses and general smart houses, it is now possible to monitor patients' health and remotely send medical data to hospitals and the doctors. And with the using of predictive analysis, it is possible to predict what will happen to the patient and dispatch medical staff even before what is going to happen. So these all sound very interesting. And so our goal here is to develop an open source solution and facilitate access to the data and generate impact assessment and monitoring frameworks. And also we would like to provide analytics toolkit for visualization and more. But in our way, we have some challenges. One of these challenges is processing the collected data. For example, we don't have any standardized formats from different sensors or different vendors. And that creates some of the problems because we have to pre-process a lot of these types of data and try to merge them together, be able to make them compatible with each other. And then there's the problem of missing data. And some of the times the sensor malfunctions and we lose some parts of the data. It is possible to try to somehow guesstimate and recover some parts of the data, but sometimes if, for example, we do not have data for days, this lost data is unrecoverable. Also, there is the idea of rate of measurements. So it will be necessary, for example, for maybe energy systems, so that we have higher measuring rates to be able to predict better. But when we are talking about traffic data, we do not have to have millisecond measurements because the cars do not move that fast. Another problem is data validity. It is very important to know that the data we are getting is somehow valid. So, for example, some time ago, it happened that one of the we were getting all the data in our platform from one of our partners, and then later we found out that they have removed that data source, but they have removed that data source, and what we were getting was just noise. Another challenge is privacy, and so one way to look into it is that we do not want, for example, import-export company to have access to medical data. And that's why we need to have a role-based system that gives everyone what they need. Data anonymization is also very important. Because, for example, I might not want to ever all the citizens in my city and beyond to know that I'm out of town. This way, someone will be able to target my house and steal things. So it's very important to anonymize the data. Another part is data security. Some of the challenges that might affect the data. So the idea is that there might be many attacks on a data platform because it holds a lot of valuable information. These attacks might be in the form of denial of service attacks, in that the attacker wants to take the platform out of access for everyone. It can be in the form of man-in-the-middle attack. So the attacker would intercept the data from the platform to the end user and might eavesdrop, might change, might do whatever the attacker wants to do with the data. The attack can be on the database itself. It can be man-in-the-middle attack on the data source, so that the attacker would change the data from the source without us noticing it. Or the attacker wants to access and modify the database. They can also try to attack and access the user credentials. So these are all very important. One of the ways to have attack this problem is to reduce the attack surface. It means to reducing the code in the entry points, reducing number of entry points, and use hardened VMs as entry nodes. Some of these are a little bit technical, but I guess they are very important to be talked about. So on the end user side, it is very important that the platform is useful for a wide range of users. This can be achieved through multiple interfaces with different amounts of details. For example, we can have basic interface, an advanced interface, etc., so that it addresses the needs for different type of users. And also, if someone is very advanced, do their own processing and everything on their own side. Dashboards are very important because they try to visualize the data. A dashboard should visualize the data. Also, they should be able to do data fusion and do some analytics, advanced analytics and pattern recognition. Anomaly detection is also very nice to happen because anomalies happen when the data diverges from the trends that we have. So the general considerations for designing the data platform is data storage, searchability, scalability, reliability, security, privacy, fault tolerance, and being open source. This is the basic diagram of our system that we are designing. So we are trying to have a monitoring system on our storage systems. We have data ingestions. The data comes from outside to this platform, and as you can see, we have many replications of this source. The idea is that we will have multiple data streams. This way, we will be able to separate each data stream and make it easier to manage for us to give the data to end users. We might not want to make some of these data available, so we just do not let the end user see this data source. So our design approach has been to divide everything into microservices, meaning that this is one of the approaches in the DevOps way of designing the system, meaning the idea is that we don't want the system to go down if we are adding something or if we are updating something. So we divide everything into microservices and just add things up together. This way the system will be available and we do not need to, the end user will not lose the data or access to everything. We wanted to use open source packages. And this is very important for us. This way, we will be able to somehow set some standards for the community, and everyone can be able to use such packages and also work on top of them. Also, we do not need to use any special type of hardware. Any user can use anything that they desire. So for our storage system, we are going to use Ceph, which is software-defined storage system. It is very flexible for us. For our search and indexing, we are primarily using Elasticsearch. But if we do not like it, or if we want to change, Cassandra, another open source package, will be nice. And for our system, we are going to use virtual machines or the containers for scalability, reliability, availability, and serviceability. These are very important. A VM is a virtual machine. It's a machine that was made programmatically. A container is just a service on top of inside one machine. And we can see it as a building, but a container is an apartment. In this way, if one of the units in an apartment has problems, has a fire problem, then all of the apartment units have this issue. So there is some security risk using a container. One solution might be to use VMs, hardened VMs, very secure VMs at endpoints, and use containers in the middle. So our design to the our approach to the dashboard has been to try to use different packages. We started with Kibana because it's bundled with Elasticsearch, and it seemed to be a very nice option. But Kibana does not give us role-based access. Of course, we can buy this. We did not want to buy anything because the idea is to use everything open source, and so everyone can have access to it. So we went with Grafana. Grafana is very nice, but it does not. It did not give us all the features that we wanted. So we decided to develop our own system from scratch. And the system that you see here is what we have developed so far. So here, for example, we have a user, and this user is admin type. And as you can see, the admin has access to many different parts of the system. However, if we log in as a different user, this will not be the case. So for this user, we have just a user, and as you can see, we do not have access to everything that the admin had access to. We can also do some other data access controls for different users, and I will show this here. So this is the main page, and we can see the number of buses running, the smart meters, and this will be different for every city based on their own specifications. So here we have a table. This table we can resize the table, and we can also filter the results for this table. So let's see. So for example, this is for the bus, and I want to see the bus number X60. And as you can see, we have been able to filter it. Bus number X71, you can see it here, it's filtered. And also, it is possible for us to filter based on each of these columns. For example, all these buses are going to the destination. These buses are coming back to the destination. And we can just go from here. Interesting, it is also possible for us to restrict the access to, sorry, just a second, to restrict the access to some of these columns. So one user, for example, from the bus company might be able to see all of these columns, but an end user that is not from the bus company might see some of these. They do not have to see all of these. So it is possible to do this in our platform. Here we can see some information, for example, about the bus company that we are working. Here we can see the map of the buses, where each bus is located, and we can also filter each route based on their number here. So for example, this is the bus number X60, and we can see that the bus is well, exactly in which place. For this one, we can have a rate of update of maybe 20 seconds or 10 seconds, so that we can try to see these buses moving almost real time. And then we've planned to have some predefined charts for each of the data providers. The charts can be zoom in, we can zoom in, zoom out, and we can see here, for example, the delays for each published line name. We can also try to take a snapshot or from the chart and visualize it here. There are other charts that we will be able to see. Here, for example, is a chart showing the aggregations. So with this, we can see the delay of the buses, but we can see the average of the delay, for example, for the last day, for the last month, for today, depending on the time that we want. So here is the published line name. And see the delay time of this, for example, bus number 1. We can see also the maximum delay. So here it is. And in another tab, we can have we will give the user the ability to create their own charts, and they can manipulate the color, the type of the chart, and so on. So let's see what we have from another data provider. This is the parking data from Eindhoven, and we can see that this is the data that we have got. This is the data in the table form, and here is the date. And we can also change the date. We plan to implement this feature for the user to change the date and just see. Here are the charts for different parking places, and as you can see, we have this peak times that we do not have many free spaces, so we can change the parking space that we have and just see which parking space is more free. So this one seems to be very crowded and has almost zero free space around this time. Here we can see the chart for the week. So this is for this bus, this stop, parking stop, all the days in the week. And we can see how this state changes. So this one is free on the weekends, but on the weekdays, it's almost full. And using this, we can also see some sort of pattern. So we can see, for example, we can also correlate this data with a calendar or with some events and know what will happen in the city. So we can see here that on Sundays, there has been an event on Sunday because, well, on Saturday actually, in here. So that we do not have much space left, and it is continuing to be here like this on Sunday. And we can see the data in the form of pie charts, as we can see here. And these are all different parking places. And this one is the one that we were getting some odd values from. Because this parking space does not exist anymore, but we still get data from. A way to avoid such things is to somehow use some sort of anomaly detection analysis on these types of data. Yes, and so here we can see the analysis tab for different types of different charts. We can have different ways that this chart is visualized. Change the color if we want to, and we can also see this parking places on the map. And we will try to see if we can update this in the later time to have, because one of the things that was shown by, I believe it was Eindhoven, that the size of the circle was changing based on how many places, what was the capacity left on each parking space. So that was a very nice idea that we might be able to implement later. And well, we are the developers. I'm Faraz Barzideh. And yes, so let's see. Thank you for your attention.
Thank you very much, Faraz, for the presentation, and sorry for wrongly introducing you as Russell. But thank you for clarifying that as well. It was a very nice presentation, very nice and good information. So I see that already Ettore has a question. So I suggest for the first few minutes we focus on questions directly to Stavanger, and then after that I will open it up to the more general questions. So Ettore, would you like to ask your question?
Yes. Well, first of all, I would like to say that I really like their platform. I think that they made an amazing job. And I am myself considering, or at least not dismissing, the possibility of creating one from scratch, you know, for Manchester. Although it might not be our first option. Anyway, the question is, what are the languages maybe, and the tools you use to create the platform? You know, the front end, the back end, whether you use Node.js, whether you use other languages at all.
So let me just go to that slide if I can. Yes. So for the data acquisition part, we have Python scripts that get the data and send it to our data ingestion nodes. This one is Elasticsearch. This is an open source package, so it was developed by someone else, and it's open source, so you can look into it. For the dashboard, we are using HTML, PHP, Java, and also Python to be able to interface with our Elasticsearch and get the data from it and visualize it.
Thank you, Russell. But is there any JavaScript involved? And if yes, what kind of packages?
Yes, there is. Our dashboard is web-based.
Okay. So do you have any name for specific libraries that you use, or specific, JavaScript libraries, for example? I don't know, like Angular or anything specific.
I believe that the plots have been, the main ones have been Plotly, and so this is what we use to try to visualize our graphs. It's an open source library that we can use. There are other libraries, but they are paid, so that we avoided them.
Okay, thank you.
Okay, are there any other questions directly to Stavanger? Okay, we can also discuss if later on another question to Stavanger comes up. We can, of course, also discuss that in the general discussion round. So I suggest to open it up to that one. And Oriol already typed a question in the chat box. Oriol, would you like to speak up and ask your question again? Oh, yeah.
Yes.
Okay.
Well, it was basically, I have not a high IT knowledge, so I'm more interested on the data visualization part. So as a citizen or as another department in the municipality accessing to this data, and we were particularly interested in how this data can be used to create nice visualization technologies, such as, for example, virtual reality or augmented reality, or even serious video games. or any other very user-friendly visualization technologies. You mentioned, of course, GIS, but something a little bit beyond this. That would be one part of the question. And the second part that was partly answered already by Ettore was about hackathons being organized open to entrepreneurs or to students so that they create new applications on the basis of the city data. What was your experience with that, and maybe an example of nice applications being created out of these hackathons or challenges? Thank you.
Thank you, Oriol. Would one of the three presenters like to answer the question or say something about it?
Yeah, well, I would say that hackathons are, or should be at least, a main aspect on these kind of things. Because before, I said in my presentation that the city needs to have a vision, etc. Now, this is easier to say than to do, I guess, because all this is quite new after all, and we are creating the path while walking. So to be fair, so the city gets a sense of where it wants to be also by observing what's going on in the grassroots, I believe. And hackathons are a very good way of tapping into this collective intelligence of a community, if you want. Because oftentimes, I mean, innovation comes from the grassroots. So this is quite an important aspect. The way we organize the hackathons, the first one at least, was such that we stopped actually with the ideas that were provided to us, but we didn't have maybe the chance or the means to push forward those ideas into a final product. But we are trying to do this for the second hackathon. So we will try to tailor the second hackathon around a more specific topic, and trying to get a final product out of it, at least a prototype, something that can be used to demonstrate a concept more than just on a piece of paper. I don't remember what was the other question about virtual reality, you said. Yeah, I think the visualization is really, really important, because this is the main way. We are visual beings, I think. I mean, this is the main way we engage with the data, we engage with information. It's not by someone telling us something or looking at the table of numbers usually. So I think the visualization is extremely important for the city's engagement in the first place, to reach to the vast majority of people. And yes, there are ways in which we can do this, also via gamification, maybe a gamification process. Click and Links is a partner of Triangulum in Manchester, and they are a virtual reality company. And they are very keen on finding ways of using this data through maybe not mobile applications, but using this data in a gamification context. They also have created it's a 3D representation of Manchester, where you can see the data that we are collecting in their geographical 3D context. For example, you can go around the city on a virtual bike, and while you go here and there and look left and right, you see this building showing you somehow it's difficult to describe, but basically it's showing you their whatever they're doing in terms of energy consumption, in terms of CO2 emissions, and etc. So all these are things that are considered, that are being explored, but it's maybe not easy to find a definite answer to what will be the use of this technologies. For example, I love virtual reality, but it seems to me a little bit elitist at this stage. Not many people have a VR headset. Not many, or even less people, if they have them, they don't go on a bike with a virtual reality headset on their head to look at data around the city. So I don't know. There's a lot to explore. We are exploring these possibilities, but I don't have a definite answer on how eventually all this will take a definitive shape and form.
Okay, thank you very much. Oriol, does this answer your question?
Yeah, it's very good to know what they did in Manchester, and also the preventions on well, not going too fast on that, and also analyzing what will be the real use by citizens, not creating applications that in the end will be used by very few people. So yeah, it was very good.
Okay, thank you. Are there any other questions from anybody else? You can now ask questions to any of the three presentations, or just very general questions. Basically anything data platform related goes now. Andrew wrote that there will be an excursion to Clicks and Links offices as part of the General Assembly in Manchester. Okay. Nice. Thank you, Andrew, for this information.
I have a question.
Yeah.
Regarding the Eindhoven's scaling up plans for the platform. They were mentioning that it's a struggle. So I would like to know their experiences on this.
Can you please repeat?
So you were talking about your platform. And one of the struggles was scaling up.
Yeah. What we had is multiple living labs working separately, organic growth, and that's of course the downside of innovation. Just try something. In some place and time, you need some governance, not preventing that everybody reinvents the wheel. So that's the goal behind, let's say, the starter kit, to have all synchronized and integrated in a kind of middleware layer. Is that what you mean?
Not exactly. So for example, what I meant was inside the data platform as a software. So let's say we want to add more sensors to our platform. So we have to scale it up. Do you have problems with that in that respect?
Not yet, because everything I told is just in development, just a beta version. And to be honest, we don't have that many sensors in Eindhoven attached already. So we don't have actually run into problems there, but are running like a kind of microservices, let's say Docker containers, which to my idea, not experience, could be easily scaled out or replicated, or just spin another virtual machine spinned up. But I don't have the experience to guarantee that.
Thank you.
Welcome.
Okay, we have time for another question. Okay, if there are no more questions, or did someone just... No? Okay. If there are no more questions, then I would like to thank you all very much, especially to the three speakers for preparing the presentations. I know this is always a lot of work, and thank you for taking the time to present today. I think all three presentations were very insightful with a lot of information, and it was very nice to learn about the different approaches in our three lighthouse cities. Thank you all to the participants for being here and for actively participating, asking questions, and yes, learn from each other. So thank you very much. I will upload this presentation. I have recorded it. It will be uploaded to the Triangulum website, where you can just click onto Press Corner and then Webinars, and then you can rewatch the entire webinar or send a link to interested friends or colleagues who would like to learn more about this topic as well. And Rick just wrote in the chat box that the Eindhoven stuff is also part of the Creative Ring Some IT during the DDW. The Design Week is that, I guess? Yeah, the Dutch Design Week, including a workshop ending with a working version of the technical starter kit on your participant's own laptop. And he included a link there. Would you like to add anything to that, Rick?
No, yeah, I like, but it's repeating. We've got, of course, in Eindhoven Dutch Design Week. There's a total program. This is one of our European partners, the Creative Ring, focusing on co-creation, but also kind of hackathon-like stuff. Well, we present the same stuff longer in more context, and we challenge all interested parties. So Technical University probably will be there to bring the laptops with administrator rights, and then we see that we can download, install, and have a working version within 2 hours. That's a challenge.
Okay, thank you very much. Okay, then thanks again to all of you, and speak to you hopefully all during the next webinar, which will take place in December. I will keep you informed at our website. Thank you all and have a nice evening.
Thank you, Bettina, for organizing this.
Thank you very much.
You're welcome.
Thank you all. Bye-bye.
Bye.